Is it okay now? Hello.
Video is not clear.
Mm, Now, sir? Is it clear, sir? Now?
Not clear. Try some other camera.
Okay, sir.
दूसरा मोबाइल यूज करो.
दूसरा फोन. उससे वीडियो. चलिए इसको. So is it visible now, sir? Hello.
Yes, sir.
Is it visible now?
Yes, sir. Yes, sir.
Same
Same blur.
problem.
Sir, still
Blur
not.
आ रहा है.
Plus. And sir, please keep it horizontal so that everybody can see it.
So this is our experimental setup, and we are going to perform this experiment on this setup. So there is a mass in between two springs attached, you can see here, and we are going to just deflect mass, and there will be some movement, to and fro movement, and from that we are going to calculate our natural frequency. So what we will do, first we will get a stopwatch. First we will deflect this mass, and this will get oscillated, and after that we will try to get the timing of each oscillation. So let us open flag option. Yes. So what we will do, we will start deflecting this spring mass system, and after that we will start a countdown in our stopwatch. So let's start this experiment. Look at here. As of now, we have our stopwatch set at 0, and we will try to capture time at its oscillation. Suppose we will first we can make a table for this. We are going to conduct this for a few number of times. So you can see here in serial number 1, we will record time in 10 oscillations, 20 oscillations, and 30 oscillations. And then we will take the average time of each oscillation, and we'll total average, and from that we will get the time period, and from that we will calculate the natural frequency. And formula is this. So let's conduct this experiment. When this mass will complete 10 oscillations, then we will record the time again at the 20 oscillations and at the 30 oscillations. So let's start this. Record time. So yeah, start. Okay, again. Start. Start. We have now 3 times at 10 oscillations, 20 oscillations, and 30 oscillations. And we will get this time. This is 5 seconds.
There's
4 seconds, 4.6 seconds, and 5 seconds. From downside up. 10 oscillations at 4 seconds. Then next 10 oscillations at 4.6 seconds. You can see the timing taken for the 10 oscillations, 20 oscillations, and 30 oscillations. And we have written down this timings here. And we are now going to take average time of each oscillations. Like for 10 oscillations, the time is 5.2 seconds. Then for one oscillation, this will be 0.52 seconds. Even cumulative is written here, 8.6, 13.8. This is for each 10 oscillation, but this is cumulative. No. 4 plus 4.6. 8.6.
अलग पता
4 seconds. Then 4.6 seconds. Yes. 20 के लिए था 8.6 seconds total. Like 30 oscillations के लिए 13.8 seconds. So average will be
4 by 10
4 by 10, 0.4,
20 4.3
4.43,
30
30 by 13.8.
एक्स्ट्रा
13.8.
क्या होगा 13.8 हो रहा है इसका
13.8 upon 13. 0.8 upon 30. So 0.46. So we will take the average of 0.4, 0.43 and 0.46. 0.46 plus 0.43 plus 0.4 upon 3. 0.43. So our average time for each oscillations is 0.43 seconds. This is the time period of oscillation. So now from that formula, we will calculate the natural frequency.
Sir, what is the average time in second case?
0.43 seconds. For each oscillations, average time is 0.43 seconds.
Okay, sir.
We have also calculated it here. You can see here. So this is our
Omega will
natural
be 2 pi
frequency.
by t.
What? Hello?
सर ओमेगा वाला 2 pi/t.
ओमेगा 2 pi by t होगा.
Yeah. Omega is 2 pi by t. Sorry for this calculation, we got it wrong. 2 pi by t, yes. Sorry, thank you for the correction. 0.43. $14.60. So we have now our natural frequency calculated here, 14.60. But we have to also perform to the second experiment. So we are going to perform the same experiment once more.
Sir, hello, sir.
Yeah.
Sir, can you repeat the calculation, sir?
Repeat the calculation, or should we do this experiment again?
Just show the data again, sir.
Okay. So the data is here, you can see. For first 10 oscillations, it took 4 seconds. For next 10 oscillations, it took 4.6 seconds. And for next 10 oscillations, it took 5.2 seconds. Did you get it?
Yes, sir.
Okay. Second experiment करना था क्या? Any questions? Hello, anybody? So I think you don't have any questions now? Yeah.
It was so quick. How was it possible to count like 30 oscillations in 4.6 seconds?
Yes, sir. Why problem, sir?
सर ये
That
इतना
is why we have,
फास्ट कैसे
that
है
is
सर?
why we
जैसे
have
कि
taken three, no? Three number of 10 oscillations, three numbers, and we have taken average of that.
sir, still like counting 30 times oscillation for a human in 13.8 seconds, it can bring
Yeah,
a lot of
there
error.
can be miscalculations, but for that we are doing averaging, na? You can perform this. We can also perform this experiment after taking like 10 number of samples, 10 oscillations,
It is
10 times.
we did it only one time only, na? So
So we want to repeat this experiment again. Hello.
No, sir,
So
we got
this
your
time we
point.
can repeat this experiment by taking 10 samples, like 10 oscillations and 10 times that sample. Then in this case, we will get more accurate result. But if you want exactly accurate result, then you will have to go with the sensors and high speed camera. What we did in last experiment, you have seen the high speed camera where we could see actually that at this point of time the oscillations is the velocity is getting zero, and after that second oscillation is getting started. So by that method we can get it accurately. Hello.
Yes, sir.
And so starting the oscillation manually can also bring errors.
What?
Starting the oscillation by pulling it manually can also bring the errors.
Yeah. In fact, there are, you can see the oxide layers on the springs. This can also bring non-linearity into the spring. But to ignore these points, we have to. Uh, these are like very few miscalculations and very few deviation from the actual result. So we are ignoring these points. And for the same, you can see also that the mass is constantly being attached to this spring. So there can also be some changes in the stiffness of the spring.
Yes, sir.
Yeah, that is the point, that we are not getting a huge deviation from our actual result. That is why we actually ignore these things. The next experiment, I think, is determination of uh, stiffness. What we will do in some other next classes. But in that experiment you will also see that how the stiffness may come in, like non-linearity may come into the stiffness. But for this experiment we can take like 10 samples, which will give us more accurate result. And for exactly precise result, what we can do, use sensors and high speed camera, what we have shown you in the last experiment. And for these calculations, we also have a laser sensor in our lab. If we could set up here, we can say like we can get a accurate result. So any other questions? Hello.
No, sir.
सर ये एक्सपेरिमेंट वन था ना
What?
कि लास्ट एक्सपेरिमेंट सर एरर के कारण नहीं हुआ है सर ये एक्सपेरिमेंट नंबर 1 होगा ना क्योंकि सर लास्ट एक्सपेरिमेंट तो नहीं हो पाया था
Yeah. In manual, it's written experiment number 6. So we will repeat last experiment in next lab. Last
ओके सर
experiment we could not do, and I think next classes we will repeat that experiment once again, so that we could get exact result for that experiment also. You can see here, like we last time we did 5th experiment, and today we did the 6th experiment, noted here. Are you able to see?
No, sir.
Isn't it visible on the
यस सर
screen? Because
Yes, sir. Visible.
Department of Mechanical Engineering Dynamics of Secondary Lab, these 10 experiments, I think we have to perform in this course. And 6th experiment today we have performed that to determine the natural frequency of a two spring mass system. And the last class, what in the last lab, what experiment we did, we will do it again. We will try to do it again, because in last experiment we could not configure the high-speed camera at time. So in the next lab, we will try to like first do all this setup, and then we could see easily to you that you can understand. Do you get it?
Sir, we'll get the lab manual for this experiment.
I think that will be telling you, Mandal sir will be telling you that. Okay.
Okay, sir.
I'm MTech second year student, and the person performing this experiment was PhD guy here. So these things will be more. So I think let's end this session. Any other questions? Okay, so thank you. Thank you for attending the class.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
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 Thank you, sir.